we take negative sign. So after calculations, integrating it from 0 to omega and this limit from 90 to theta, after solving we get omega as root 3g by L into cos theta, like here. Next question is, we need to find omega at theta is equal to 0. Initially we assume that theta is 90. So in this equation substitute theta is equal to 0. So we get omega is equal to root 3g by L into cos theta, which will be root 3g by L. Next is, we need to find centripetal acceleration as a function of theta, and the point here is x is equals to L by 2. So we know that centripetal acceleration is r omega square. R here is L by 2, omega square is 3g by L cos theta. So on solving this, we get centripetal acceleration as 3g by 2 into cos theta. Next question is, we need to find tangential acceleration as a function of theta, and the point here is x is equals to L by 2. So we know that tangential acceleration is r alpha. R is L by 2 here and alpha will be alpha. Alpha we have calculated at 3g by 2L into sin theta. So on solving this, we get tangential acceleration as 3g by 4 into sin theta. Next, we are being given a question on that there are certain forces which are acting tangentially on a circle, and there are three forces over here. We need to find the net force. So we take the components. This is x-axis, this is y-axis. So this force will be F cos 53i plus F sin 53j. Similarly, this force will be 3F cos 37i minus 3F sin 37j, and this force will be 2Fi. So after adding all the forces, we have finally, after solving this, that force is equal to 5Fi cap minus Fj cap. So this is the net force after adding all the vectors. Next is magnitude of the net force. So this is done by squaring the I cap term and the j cap term. So we have root 26F over here. Now next question is, we need to find the net torque. So you can see that about the center, this force will produce a torque Fr. So for calculations of net torque, we can see that this force will produce torque Fr. It sense will be clockwise. This force 3Fr and this force will 2Fr. Taking clockwise sense as positive and anti-clockwise as negative, we have net torque as Fr plus 3Fr minus 2Fr, which sums out to be 2Fr. So we can say that net torque about the of the forces will be 2Fr in the clockwise sense as per the system of forces is concerned.